Hi, this is Mrs. Yenny, and what I'm going to do right now is review What Do You Expect? Investigation Problem 1.1. And this is the problem where April and Tiyoko have invented a game called Match No Match. And in this game, players take turns spinning a spinner like this one shown here, half blue and half yellow. If the resulting two spins are a match, like what you see here, then regardless of who made that spin, player A receives a point. If the resulting spins result in a no match, then regardless of who made those spins, player B gets 2 points. So that's the basic gist of the game. So as you can see here, I went ahead and I played it 24 times. And of those 24 times, 10 of those times I had a match, and 14 of those times I had a no match. All right. So you can see that player B won in my example by a long shot. So let's go ahead and review the questions here. So the first thing that we're doing in matching colors is really looking at experimental versus theoretical probability. So to find the experimental probability of a match, I need my experiment data. So anytime you run a game and collect data like this, that's considered doing an experiment. So our experimental probability is based on this data. The probability then, experimental probability of spinning a match was 10. I have 10 matches here out of 24, which of course reduces to 5/12, which is approximately 42%. All right, so the experimental probability of a no match then, if we look back at our data, I can see that I got a no match 14 times out of 24, which reduces to 7/12, which is then approximately 58%. All right, so now I'm going to list all the possible outcomes of a turn. To do that, I'm going to make a counting tree. And to make a counting tree, I always like to start with the word start. And then what I'm going to do is have branches to represent the first spin. And on the first spin, of course, I could have landed on a blue or a yellow. Now I'm going to have branches that come off of each of those to represent the second spin. So even if I had a blue on the first spin, I could have a blue again on the second spin, or a yellow. Same thing here. If I had a yellow on the first spin, I could still get a blue or a yellow on the second spin. And making a counting tree really helps us to list all of our possible outcomes. So now I'm going to abbreviate B for blue and Y for yellow and list all my outcomes. So here I have blue, 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 yellow, yellow, blue, and yellow, yellow. And I can see now that I have 4 possible outcomes. This is going to help me now to calculate the theoretical probability. Remember, the theoretical probability is the probability that we get when we just analyze a situation. So we're using this information to help us here. The theoretical probability then of a match, I can see here there are 2 ways to get a match out of my 4 outcomes. So the theoretical probability of match is 2 out of 4, or 1/2, or 50%. The theoretical probability of a no match, I have 2 ways here of getting a no match out of 4 possible outcomes, which results in 1/2 or 50%. So now the question is, are the outcomes equally likely? Yes. What that means is there the same chance of getting each of these 4 outcomes? Yes. Each outcome has the same chance of occurring. Okay. See, I'm going to compare my experimental and my theoretical probabilities. All we're doing here is just really looking at how close were our 2 probabilities. Did they match? Did the theoretical and experimental probabilities match up, or was there a discrepancy? And so when I look at my match, my experimental probability of a match was 42%. My theoretical probability of a match was 50%. So that means that if I compare my theoretical and experimental probabilities of a no match, I am comparing 58% with 50%. Now the reason that there's such a discrepancy here is because think about how many turns we took. We only took 24 turns, which isn't a very large number, and certainly mathematically speaking, it's not a large enough number to notice much of a difference. But theoretically, I want you to really think about what would have happened had you played 1,000 times. So think about that. What would have happened, do you think? And when I say what would have happened, how do you think your experimental and theoretical probabilities would compare for both the match and the no match? All right, so the last part of the question is this game fair? Well, we know that there's the same chance of spinning a match as a no match, but it takes more than just the same probability to make a game fair. Because as you know, we get, and I'm just going to make this one a match, we get 1 point for a match, and right now we get 2 points for a no match. That makes the game unfair. So to make the game fair, we're not going to change the spinner itself, and we're not going to change how the game is played, but instead what we're going to do is we're going to adjust the points. So by simply saying, instead of getting 2 points here, player B should get 1 point, we have now matched our probabilities. Or of course our other option would be player A could get 2 points as well. As long as they have the same number of points combined with their probabilities to equal the same overall chance of getting the same number of points after a certain number of trials, we would say that the game is then fair. All right, thank you for listening, and see you on 1.2.